Hey guys, it's Mrs. Balch. I'm going to do some problems from topic 1, lesson 3 today on solving equations with a variable on both sides. I'm on page 21 in the student workbook, and I'm going to start with problem 11. Okay, so the first problem that we have here asks us, how do you know whether an equation is an identity, and how many solutions does an identity have? So we talked about this in class. When you see that, like, you get something that looks like mx plus b on one side and it equals mx plus b on the other, those are the same equation on both sides, so it's going to have infinite solutions. So m and b could be any number. Maybe it says 3x plus 1 equals 3x plus 1. Because the equations are exactly the same, whatever x is on this side is going to be the same thing on this side. They're always going to be equal. It doesn't matter if I put in 1 here, because I'll also put in a 1 here. If I put a 5 in here, I'll also put a 5 in here. So they have infinitely many solutions. Okay, so that should help you with explaining question 10, and I think you have to do question 13. I don't remember. All right, question 16 here. 5x minus 4 equals 4x. Right, this is a lot like the one over here that you have to do first. Now, I know I told you I usually like to subtract my small variable first, but if I did my little line here to make sure I'm keeping my equation balanced, if I subtract 4x, then there's not going to be anything on this side. It would be a 0 over there, and that we can't have that. You got to solve for something. So if I did minus 4x here, it wouldn't work. So I'm going to subtract the 5x. So 5x minus 5x cancel out. I know that there's a subtraction sign there, and a lot of you want to then add 5x. The subtraction sign is in front of the 4. Okay, so when you bring this down, now that's just a negative 4. So then I'm going to subtract 5x on this side, and 4x minus 5x gives me negative 1x. Okay, now you can divide by the negative 1 if you want to. I'm going to do that just to show it. But I know that if I'm flipping this sign, I also flip this sign. So when I divide by negative 1, this becomes x, and this becomes positive 4. So x equals 4. And I'm going to circle my answer so I can see it. All right, I want to do question 22 next because there's a lot of distribution going on here. You know, I like to get rid of as much as I can outside of the parentheses. In this case, since there aren't like multiples of each other, I can't divide by anything to get rid of them. So I'm just going to have to go ahead and use the distributive property. So I do 5 times n and 5 times negative 7. And 5 times n is 5n. 5 times negative 7 is negative 35. And on the other side, I do the same thing. 2 times n is 2n, and 2 times 14 is positive 28. Now I can subtract 2n and those will cancel out. And I'm going to add the 35. See, if I move a variable on this side, then I have to move the whole number from this side. So now I can do 3n equals 63. And once you divide by 3 on both sides, you get n equals 21. There. Number 26 is really similar to 27. So I wanted to make sure that I do that because when I saw 27 today, it took me a second to think of how to do it easiest. So when you have all of this over 2, that means I'm dividing the whole thing by 2. And all of this over 3, this whole thing is being divided by 3. So the easiest thing to do is to multiply everything by the least common multiple. And the least common multiple of 2 and 3 is going to be 6. So I'm going to do times 6 here. No, sorry, honey. I'll get you something else in a little bit. I'm doing a video right now. And I'm going to do times 6 on this side too. Since all of this is going to get multiplied by 6 and then divided by 2, I can just take the 6 and divide it by 2 right now. And that gives me a 3. And then 6 divided by 3 gives me a 2. So now I just have to take the 3 and multiply it by everything here, and the 2 and multiply it by everything here. Okay, I know this is a little tricky. So 3 4x plus 6 equals 2 times 3x minus 15. Now I'm going to use the distributive property. 3 times 4x is 12x. 3 times 6 is 18. 2 times 3x is 6x. And 2 times negative 15 is negative 30. Now I'll subtract 6x. Let me see if that'll, there we go. And I'll subtract 18. So I get 6x left on this side and negative 48 on that side. And the last step is just to divide that number off the variable. So the 6's will cancel, and x equals negative 8. I don't mind if you guys write like this as long as you're not writing over another problem you need to do, or, you know, use a separate piece of paper if you take a lot of space up and just upload that. All right, 36 I wanted to do because I saw 32 has some stuff with some fractions going on and lots of parentheses here, making this a little confusing. So I'm going to work from the outside and go in because I can't do anything on this side at all. There's just the x there. So 1/4, to cancel out a fraction, remember you multiply by the reciprocal. And the reciprocal of 1/4 is 4. So I'm going to multiply by 4. And because the 1/4 is the only thing outside of the parentheses on this side, you only multiply 4 and 1/4. And they cancel. And then on this side, you also have to multiply by 4. So this will be 4x. And on this side, we still have 2 times x minus 1 plus 10. All right, so I'm going to go ahead and distribute this because I can't do anything with the 10 and the 4x. So 2 times x is 2x. 2 times negative 1 is negative 2. And then you got to bring the 10 down and bring the 4x down to the next row. Now I can combine like terms here. So -2 and +10 is +8. And I'm going to subtract the 2x. So I get 8 equals 2x. And when I divide by 2, I get x is 4. And then I just want to do one more problem. Number 37 is a lot like 38. So it doesn't really matter when I multiply by 2, but I'm going to move the 4 over first just because it's easy. I'm going to add the 4 there. Now I can multiply everything by 2 on this side. All of this has to get multiplied by 2 because there was no parentheses. Okay. When you have all of this being divided by 2, when you multiply by 2, it doesn't touch this. But if it helps you to think about putting parentheses here, you can. A lot of times they will, because really this whole thing's being divided by 2, so it's kind of like they already have parentheses there saying this is a closed operation. So the 2 cancels out the 2. And just the 6x plus 8 comes down. And then on the other side, we're going to do 3x plus 4 all times 2. And 3x plus 4 times 2 gives me 6x plus 8. And I'm not going to go any further because I know what the answer is to this. Since this side matches this side, this is an identity. And it has infinite solutions. I don't know if this was or not. I didn't do that one. All right, that was it. I hope this helps you guys. If you have any questions, make sure you jump on Remind or ask me tomorrow in class.